Okay guys, I want to show you a couple schematic drawing diagrams that my Elmer had sent me. One of my Elmers, who passed many years ago, had sent me in 1999. This was my old address here. 1999 he sent me this, and his name was Bill, and his call sign was WA2WEJ, which is right here. Good old Bill. He was one of my Elmers. The patience this guy had with me, I can't even tell you. So he hand-drawn 3 schematic diagrams for me with a pen, just on pencil and paper. And what he did is he drew out here, which I actually built these. I only find one of them upstairs in my apartment, but this is actually a phase meter that he designed. So here's your RF input, which would be like a SO239 connector, going with a wire going through a toroid, and here's your output. On the opposite end of a enclosure, like a box, will be another SO239 connector going to your antenna. So this toroid has what they call a bifilar winding, 2 windings of wire, and it shows where the wire goes actually through the toroid, and 1 wire goes right down and into a diode. The other wire goes number 1 wire and number 4 wire goes right down into diodes. So what those diodes do, in order to make a meter movement, this is a center meter that is used for this specific phase meter. So when it sits in the center and you key up RF, the RF goes through the center wire here, going through the toroid, and the RF goes onto the transformer, and this transformer sends the energy down to the diodes, and the diodes convert the RF into DC, so it makes this meter move. Because this is a DC meter, you see how it says plus on the left and minus on the right. It's a center meter, so this is a basic, simple schematic showing you, resistors, capacitors to ground, 10K resistor, going to the meter. On the opposite end here, it's showing you similar stuff, 5 to 10 picofarad capacitor going to ground, 100K resistor going to ground, a 0.01 100 volt disc ceramic capacitor going to ground, and then a wire going right to the negative end of the meter. So this is the little intricacies in between, before it actually sends the DC down to the meter. But and how you calibrate this meter when you're pumping RF through the meter, say if you want to check 146,520 for instance, what you do is you pump a signal on the input of 146,520, and on the output you put a dummy load, and on that dummy load, so here you have an air variable capacitor here, right? 5 to 10 picofarad small PC air variable capacitor. Okay, so once you're pumping the RF from the input, say if it's even 5 watts, when you're pumping the RF into the input and you got on the output a dummy load, what you do is you key your microphone, and this air variable capacitor, you tweak it. You just turn the capacitor until this meter is standing straight up like that. It's not to the left or to the right. It's straight up and down. That is the way. That's how you actually calibrate this phase meter for whatever frequency that you're going to be using it for. Okay, and here's some of the details of the diodes and that you need, and so forth. So in other words, once it's calibrated to 146/520, and now it's calibrated, and you take it out of line, so when you hook your radio up to your antenna, or you put the phase meter after the radio and it goes to the antenna, you're going to be able to see what the phase angle, what the phase is of your antenna system. So he also gave a little more detail about the phase meter here. So meaning that, and here's the meter again, but this is a little different view of a schematic, what it looks like. He did it in block figures here. So you got your transmitter, your amp, your power, SWR, your phase meter, your matching network, etc. going to your antenna, okay? And a little block diagram. Here's your components. And here's basically what's happening with the meter. It's showing inductive reactance is low in frequency or below resonance, and if it's high capacitance, it's capacitively reactive, meaning high in frequency and above resonance. So in other words, once this meter's calibrated, like I said, you basically, what you do is you make adjustments to your antenna to try to get that meter to where it's matched the center, in the center area. If it swings, like it says, if it swings low in frequency, it's below resonance. If the meter swings high in frequency, meaning to the right, it's above resonance. So I know this might be a little overwhelming to some people and a little like what the hell is this guy talking about? But there are some people out there that are interested in this stuff. So I just wanted to share this stuff because I miss my Elmer. He was the best. He was one of many Elmers I had. So, and here's another very sensitive a digital / analog RF sniffer, okay? Which means you could sniff out RF, which I actually built on inside the very insides of like a radio. Like if there's stray RF getting into one of the circuits, this thing is perfect to be able to detect that. Like many years ago when I was building a 6 meter kit, I had RF coming off the leg of a very small capacitor, and in order to suppress that RF from getting into other parts of the circuit in the actual transmitter itself, I had to put a little bead, a ferrite bead, over the leg of the capacitor to suppress the RF from generating into other parts of the circuit. So anyway, there's this call sign, WA2WEJ. Never forget you, Bill, and I appreciate your patience that you had with me for many years. So there you have it, another diagram of a pretty basic RF sniffer. Shows you the components and everything. Shows you the meter. So when it's sniffing out RF, the meter will move, and it's a frequency conscious meter, meaning, you know, whatever band you're using, you have to use the proper components that are frequency conscious to whatever band you're testing or whatever you're using it for, whether it's 1 megahertz up to 30 megahertz or 50 megahertz all the way up to 440 UHF, or even above that up into 900 megahertz or 1.2 gigahertz, etc. You know, even into the microwave bands, you can buy these, you can make these things, but you have to you have to start shifting from microwave components and things like that to make that kind of like work out. So there you have it. My good old friend Bill's patience and the way we did things years ago. You know, before our smartphones and internet and anything like that. We sent each other letters in the mail and talked over the radio to each other.